This is mathheals.com, where you'll find more links to YouTube math videos and computer science. And let's take a look at hypothesis test for a population mean using the p-value approach by hand. Now, requirements: the samples obtained using simple random sampling or from a randomized experiment. The sample has no outliers, and the population for which the sample is drawn is normally distributed, or the sample size n is large, n is greater than or equal to 30, and the sample values are independent of each other. Now, most stats books have claims about the mean where sigma is known and where sigma is not known. They're like two separate sections. This particular edition, the authors opted to go with always testing claims where sigma is not known. So realize if you're in a different stats course, you may need to do both of them. And I'll go over these steps here in a second, but let's skip down to our problem. Okay, number one. We've got the mean amount of fluid in a bottle of lens cleanser is 59. So mu would be 59. A researcher believes the mean is actually lower than that. Sounds like our claim. So lower than 59. Okay. 15 bottles are sampled. Sounds like our sample. So n equals 15. And the mean is found to be 58. So that'll be x bar since it's talking about the sample. With standard deviation at 1.2. So S will be 1.2. Test the claim based on this information and alpha is equal to 5%. So alpha is equal to 0.05. Now if we go back up to our steps, step 1, write down a shortened version of the claim. Well, we did that. Step 2, come up with a null and alternate hypothesis. H naught always has equal part on it. Well, we're talking about mean, so this would be mu. Lower than is a less than symbol. So that's going to go here. If that's less than, this has to be greater than or equal to. Now the only symbols you can put on H1 are the less than, greater than, or not equal to. Only symbols you can put on H naught are less than or equal to, greater than equal to, or equal to. When we had a lower than, we had a less than, we knew it had to go in here. It's the only place you could put that symbol. So our claim matches H1. Now, the convention's been recently to always put an equals on H naught. Now, H1 can be any one of these, but on our null hypothesis, H naught, they always put an equals no matter what. Now, I don't like that. I like this convention because they're opposites of each other, and I find students click better with this. Gives you the same answer in case you're wondering. Okay, now we're down to step 4. Find your test statistic. So we've got T naught is equal to x bar minus mu naught. Let's see if claim. Okay, yeah. Just kind of skip ahead, just make sure I didn't miss anything. Then S over square root of n. Okay. Well, x bar we said was 58. Mu naught, this is a number off of our claim H naught H1, which would be 59, over S, which is 1.2, divided by the square root of n, square root of 15. Now when you put this in the calculator, you have to make sure you put parentheses around top, parentheses around the bottom. So let's see what that gives us. So I'll put a beginning parentheses, 58 minus 59, closing parentheses divided by beginning parentheses 1.2 divided by second x squared 15, square root of 15. Enter. And we get negative 3.23. Now I say look up the absolute value of the t-score from step 4 in the t-distribution table. So we're not going to look up negative 3.23. We're going to look up 3.23 with the t-distribution table. We need degree of freedom. Degree of freedom is 1 less than n, so degree of freedom will be 14. Again, remember your degree of freedom is n minus 1. So 15 minus 1 or 14. Well, let's go look that up. Good. Here's t-distribution. So we're looking in the row that has degree of freedom of 14. So we're looking at this row right here, going all the way across. And we're looking for 3.23. Now, odds of you actually finding this number are very, very low. So you're looking for a range. Okay, so degree of freedom of 14, 3.23. That'd be between 2.977 and 3.326. So it falls in this range right here. Which means I come up here and it's between 0.0025 and 0.005. So our p-value is somewhere in that range. Again, what I did is I went to the row with our degree of freedom, and I looked for our test statistic, and looked for the numbers it's between. It's between 2.977 and 3.326. And so I went up there to get this value, and I went there to get this value. And it's between these two values. Now that's about all I can say about the p-value. I don't really like this using tables. If you use technology, you get a precise answer. But I wasn't even going to actually create this video, and then I thought, I'm going to go ahead and do it. Just so if you're stuck someday using tables, you don't have technology, then you see this method. And it's not a perfect method. I mean, it's very imperfect. Okay. If p-value is less than alpha, well, we don't know where our p-value is, but it's between 0.0025 and 0.005. Now, both of these are less than alpha, so we're fine there. So it says reject H naught. So for a conclusion, we're going to reject H naught, which means we accept H1. And since our claim matches H1, that means we'll accept our claim. Problem with this is if you come up with this range here, and your alpha is actually in that range, whatever you choose for alpha, then that causes a problem because you don't know whether to reject it or accept it. So it's kind of imprecise. You know, if you're going to do it by hand, I'd say use a classical method on these. Let's look at our second one here. Okay, mean amount of fluid in a bottle lens cleaner is 59. I'll learn to speak someday. So mu is 59. Research believes that the mean is different than that. So claim is different than 59. Tests, or wait a minute, 35 bottles are sampled, so N is 35. Mean is found to be 63, so X bar is 63, with standard deviation 2.3. That's all information they give us. Alpha is 1%. We know we need our degree of freedom, which would be 1 less than N, which is 34. Okay, step 1, write down a shortened version of the claim. We got that. Step 2, come up with a null and alternate hypothesis. Well, these would be mu's different than that implies a not equal to, which goes on H1. If that's not equal to, this has to be equal to. 59. Obviously our claim matches H1 since they both have the same symbol. Find test statistic. So T naught is equal to X bar minus mu naught over S divided by square root of N. X bar is 63 minus mu naught, which is 59, over S, which is 2.3, divided by square root of N, and N is 35, so we got square root of 35. Again, the key to putting these in your calculator is parentheses around the top, parentheses around the bottom. Okay, so beginning parentheses, 63 minus 59, close parentheses, divided by, beginning parentheses, 2.3, divided by, second x squared for the square root of 35. 10.29. Okay. So we're going to look up 10.29 with a degree of freedom of 34. So let's see what we get. 34. Be right down here. And kind of a big test statistic, isn't it? I guess that would be different. 63 and 59, they're pretty widely apart. Widely apart. I just woke up a little bit ago. So obviously I don't have 10.29 here, so it looks like it's greater than the 3.601. So notice how these go. As it goes to the left, it becomes greater than, which means it's less than this. So my p-value is less than 0.0005. Can't say much more than that because it's greater than that. Now we got a special note on our two tails. Actually, I didn't. This is the step we're doing, step 5. It says if it's two tails, then multiply the p-values by 2. So I'll multiply this by 2. I'm not very good with decimals. I think it gives us that. Let me double check. 0.12345 times 2. Not that I can't put it in the calculator, right? Yeah, 0.01. So, so it's less than this. Well, what is our alpha? Alpha is 1%. So for our conclusion, it's less. We don't know what p-value is, but it's less than this, and this is 1%. This is 0.0010. Then alpha is greater. So p-value is less than alpha. It says reject H naught. So we'll reject H naught. And that means we'll accept H1. Now books will not use the word accept. They'll use do not reject. And since H1 matches our claim, we'll accept our claim. I like the word accept, because accept and reject, students seem to click better with it in terms of being opposites of each other. Now, just for fun, let's go put this one in the calculator and see what our p-value is. So press stat, go over to tests. I want to choose t-test. Given summary statistics, so I'm going to right arrow over, press enter on stats. Come down here, it's 59. X bar is 63. S is 2.3. N is 35. The symbol we're using here is not equal to, and now choose calculate. Look what our p-value is. 5.59806 e to the negative 12. That e to the negative 12 means you move your decimal point 12 places to the left. So I'd have 0.000000, that many zeros. 559. Very, very small. So when I say it's less than this, well, it's true, but it's very imprecise. I'm not crazy about the p-value approach by hand. I like technology when you use the p-value because you get exact values. It's not guessing. It tells you exactly what the value is. Now, you can do some of this stuff by hand, but it's beyond the scope of introductory stats course on how do you calculate the p-value by hand. Let me save this, and we'll look at our next problem. What am I doing? Print. There we go. Well, that's just totally bizarre. Wonder why that changed. Huh. Changed from last night. Just decided it wanted to put it in a different format for me. It's messing with my mind. Population mean, p-value approach, and by hand. There we go. Next problem is you have to do a lot more work with. It says the mean amount of fluid in a bottle pop is 16.9. Research believes that the mean is more than that. 10 bottles are sampled, resulting in the following data. And we know from our formula here we need X bar, we need S. So first thing I'm going to do is I'm going to find mean and standard deviation of this. And then we'll do our claim. So we've got 16, 16.1, 17, 17.5, 17.2, 17, 17.5, 16.3, 16.7, and 18.7. Okay, looks right. I should have these in my calculator because I've done this problem with the classical approach by hand. So let me double check I do. I deleted them. That's not good. So let me put them back in there. You don't need to see this, what I'm doing, because I'm kind of cheating a little bit here. I'm using my TA3 that I have at my desk. Okay. Why is that cheating? Well, we're supposed to be doing this by hand. Okay, so now if I add all these up, we're going to get 170. Now I've made this one come out nice. So then our mean, our X bar, is going to be the sum of our X values divided by N. So we're going to have 170. I think there's 10 of them, which gives us 17. So then up here, I'm going to create a new column, x minus x bar. So I got 16 minus 17 equals negative 1. 16.1 minus 17 equals negative... I hate decimals. Let me go. Let's see. Minus 17. Negative 0.9. And we have 17 minus 17 equals 0. I'm just taking each x value, subtracting the mean. 17.5 minus 17 equals 0.5. 17.2 minus 17 equals 0.2. 17 minus 17 equals 0. 17.5 minus 17 equals 0.5. 16.3 minus 17 equals negative 0.7. 16.7 minus 17 equals negative 0.3. 18.7 minus 17 gives us 1.7. Well, then we need another column, x minus x bar squared, so we're going to square each one of those numbers. Negative 1 squared is 1. Negative 0.9 squared is equal to 0.81, I believe. 0 squared is 0. 0.5 squared is 0.25. 0.2 squared is 0.04. 0 squared is 0. 0.5 squared is 0.25. Negative 0.7 squared is 0.49. Negative 0.3 squared is 0.09. And 1.7 squared, I think, is 2.89. Go double check that. Okay, 1.81, 0.25, 0.04, 0.25, 0.49, 0.09. Yep, that looks good. I'm going to add together L3. And that gives us 5.82. So add these, and that gives me 5.82. Okay, so S is equal to square root of the sum of x minus x bar squared divided by n minus 1, which gives us 5.82 divided by 10 minus 1. So I got 5.82 divided by 9. We got 0.80415.8721. Okay, well, now we have those two, so we can proceed with our problem. It says the mean amount of fluid in a bottle pop is 16.9. Well, that's mu. As it says, mean doesn't refer to a sample at all. Researcher believes that the mean is more than that. 10 bottles are sampled, so n is 10. And we found that x bar was equal to 17, and s is equal to 0.804155.8721. Test the claim based on this information at alpha is equal to 10%. Okay, that's all the information they give us. Let's write down our claim then. Researcher believes the mean is more than that. So greater than 16.9. Okay, write down a shortened version of the claim. We did that. Come up with a null and alternate hypothesis. These would be mu's. Greater than has to go on H1, so that'd be greater than 16.9. If that's greater than, this is less than or equal to. This matches H1. That's step 3. See if claim matches H0 or H1. Step 4, find test statistic. So T0 is going to equal to x bar minus mu naught over S divided by square root of n. X bar was 17 minus mu naught, that's the number off of our claim, which is 16.9. divided by S, which is 0.8041558721, divided by the square root of the n, which is square root of 10. So parentheses are on top, parentheses are on the bottom when plugging this in. Okay, so I'll put a beginning parentheses, 17 minus 16.9, close parentheses, divided by, beginning parentheses, 0.804155 8721. Divided by square root of 10. So second x squared for the square root, then 10, and enter. We get 0.39. Okay, step 5. Look up the absolute value of this in t-distribution table. So we're going to look up 0.39 with degree of freedom of 9. Remember, degree of freedom was 1 less than n. Okay, 9. I come up here. 9 is this row, and I'm looking for 0.39. Well, it looks like it's here's 0.703, so it's going to be less than this, which then, remember how this goes. These become greater as they go to the right, left. So p-value is going to be greater than 0.25. Now that's all we can say. That's not very precise, is it? You know, it's greater than 0.25. Well, what's that? 0.9? Is that 1? 0.3? 0.26? But it's as good as it gets. So if p-value is less than alpha, well, p-value is 0.25 or greater than 0.25, and alpha is 10%. So it's not less than. P-value is greater than alpha. It says you accept H naught. So our conclusion, we accept H naught, which means we'll reject H1. And since our claim matches H1, that means we'll reject our claim. And let me save that. Okay, hypothesis test for population mean p-value approach by hand. Page 2. There we go. Stop the recorders. That's the end of that section.